Alrighty, my friends, we're going to show that the vaporization or boiling of water is spontaneous, so it occurs without additional energy, just kind of on its own, at 101 degrees Celsius and 1 bar. And there's a variety of different ways to show that the phase change of a substance is spontaneous or not. I have a few different ways in the description below, but in this video, we're going to use the fundamental equation of chemical thermodynamics, which is change in Gibbs energy G is equal to the change in enthalpy H minus temperature times the change in entropy S. And in this form, temperature is constant, which is fine because we're boiling it at a constant 101 degrees Celsius. Now we're going to make another assumption. We're going to assume that the enthalpy change and the entropy change is temperature independent. So what this means is that it doesn't matter what temperature we boil the water at. You could boil this water at any temperature, and the change in enthalpy will be the same. That's what we're assuming. It won't be, but over small temperature ranges, it's approximately constant. Okay, so with that assumption and a little bit of notation, we have this equation in just like this one here. And don't freak out, this is just some notation to make it specific to this question. This is the change in vaporization or boiling of Gibbs energy at 101 degrees Celsius. And this is in its standard state, so the process is occurring in standard state, which means it's at a constant pressure of 1 bar, and it's pure water. And that's equal to the change in enthalpy minus temperature times the change in entropy. And note that we want the change in Gibbs energy at 101 degrees Celsius. Here we have the change in enthalpy at 100 degrees Celsius and entropy at 100 degrees Celsius. We can do this. We can make this assumption because we're assuming that these changes, delta H and delta S, are temperature independent. Okay, so we need to solve for this equation. We're first going to solve for the delta S, the change in entropy. And to do that, we're going to look at 100 degrees Celsius, which is 373 Kelvin. And at 100 degrees Celsius, the liquid water is in equilibrium with its gas phase. And if it's in equilibrium, then the change in Gibbs energy is 0 at that temperature. So we can plug that into this equation right here. And we can solve for our change in entropy, delta S. If we do that, we have this expression right here. And we can now plug that into this equation right here. And now we have everything in terms of the change in enthalpy, which is good because that's kind of all we're given in the question. So we can plug in our numbers, and if we plug this into the calculator, we get a change in Gibbs energy of negative 0.139 kilojoules per mole. It's negative. A negative delta G means the process is spontaneous, and if it's spontaneous, then the change in entropy is greater than 0. For fun, we could calculate this change in entropy by using this equation here. This comes directly from the second law. I can derive this if you want, let me know. But if we plug in our value for delta G, this is positive because this negative cancels out with this negative. We get a value that's greater than 0, which means that the total entropy increases when the water boils at that temperature. Great. All right, y'all. Hope you got some value from it. Hang in there. Thermo's not an easy course, but you can do it if you keep doing many problems. Best of luck on your midterms, final exams, and all that. And thanks for watching. I'll see you in the next video. Cheers.